So, good morning, students. Today we will study about the voltage commutated chopper. So, basically, before we start this topic, so let us review some basic points about choppers. Okay, so that it becomes easy for us to understand this topic. Now, chopper is basically a DC circuit. Okay, if you have understood it very clearly. A chopper is a DC circuit. Its input is DC, its output is also DC. Now, because the input of chopper circuit is DC, so the thyristors which are used in chopper circuit are commutated or turned off because it is required to turn off the SCRs so that the modulated or manipulated or varied output voltage can be obtained as it is required from chopper circuit. Okay, so the chopper, the thyristors basically which are used in this in the chopper circuits are commutated or turned off. Turning off an SCR is known as commutation, right? So to commutate the SCR in chopper circuit, we need to apply some commutation techniques. Okay, so we have certain commutation techniques which we have studied in our first unit. So among those commutation techniques, the forced commutation technique is generally used to turn off the SCRs which are used in chopper circuitries. Okay, though a chopper circuit in so basically in chopper circuits, the chopper is basically shown with a symbol of switch that you must have noticed. Okay, that switch is basically enclosed in a dashed square, right? And that is a symbolic representation of chopper because symbolically we mean to say that a chopper is a switching device, okay, which is being turned on and off. But actually a chopper itself consists of SCRs and the commutation circuit, right? So the purpose of today's lecture is to understand how the SCR of a chopper circuit is turned off and then turned on, right? So based on the commutation technique and that too the forced commutation, the chopper circuit is basically it utilizes the forced commutation, and that forced commutation we have two categories, and those two categories are the voltage commutated chopper and second one is current commutated chopper. So today we will study about the voltage commutated chopper. Okay, means a chopper in which the main SCR, I'm talking about the main SCR, is turned off by using a reverse voltage across it. Okay. So how that reverse voltage is applied across the main SCR and how the commutating elements or the commutation circuit that is present in the chopper circuit commutates the main SCR and how the whole operation of such chopper is achieved. That is the purpose of today's lecture. So a voltage commutated chopper is one of the earliest chopper which was widely used. Means this chopper used to be widely used in earlier days when the chopper circuits were designed. Okay. And the application of this chopper is in high power circuits basically, where the load fluctuation is not very large. Means the load remains, the electrical load basically that remains constant. Okay, fine, that does not fluctuate. Okay, so that fluctuation of load means fluctuation of load current. So that means if load is assumed to be non-fluctuating or constant throughout the operation, that means the load current is also constant throughout the operation, right? And this chopper circuit is also known as parallel capacitor turn off chopper. means we use a capacitor to turn off the main SCR of the chopper. To turn off the main SCR of the chopper. Up till now, we have seen in the chopper circuitries that the chopper is basically shown in a square box like this. Like this. Okay, but this chopper circuit is an elaborated circuit basically, so that we will study today. So this chopper circuit means the voltage commutated chopper is also known as parallel capacitor chopper. Parallel capacitor turn off chopper means the capacitor is used to turn off the chopper. How? That we will study. It is also known as impulse commutated chopper means impulse commutation is basically used here. Or a classical chopper means this is the oldest type of chopper which was earlier used. Okay, and nowadays also it is being utilized or used. So this is the circuit diagram of main chopper. So you can see here these dashed lines, this one, this square, it encloses certain components which comprises of the main SCR T1. This is the main SCR T1, and then auxiliary SCR which is TA, the capacitor which is also known as commutating capacitor, an inductor which is the commutating inductor, and a diode basically. All these components are represented with a simple symbol of switch enclosed in a square box, and we call it as a chopper, CH. Right? So now we will see how this whole circuitry works. Okay. So you have a freewheeling diode also here because the load comprises of an inductor. So the current through which is stored in the inductor in form of the magnetic energy needs to be dissipated when this part of the SCR is cut off from the load, or you can say the load is cut off from the supply. When the load is completely cut off from the supply means the load current does not flow from supply. So that means in this case, whatever current is stored in the inductor here, that currents flow through freewheeling diode in form of load current. Okay, it dissipates like this. Now, T1 is the main SCR, T is the auxiliary SCR, C is the commutating capacitor, L is the commutating inductor, D is a diode, and FD is the freewheeling diode, and the load is RLE type. Load is RLE type. So basically in step A, type A chopper, we use RLE type load, and also in type E chopper, right? So earlier we have studied the categories of choppers on the basis of the quadrant in which they are operating. So we have type A, 1 quadrant chopper, type B, 2nd quadrant chopper, type C, 2 quadrant type A chopper, then type B chopper, 2 quadrant type B chopper, then type E chopper means which is 4 quadrant choppers. And quadrant means here basically it signifies the flow of power or the direction of voltage and current basically. If the direction of voltage and current is positive with respect to the reference, there has to be some reference basically. Okay, positive and negative with respect to some reference. Okay, so current is positive when it flows from source to load, and voltage is positive when the upper terminal of load is positive with respect to the ground terminal or negative supply. Right? So here also we have shown certain notations for the voltages and currents. You can see the direction of load current is this. Let us say this terminal is X and this terminal is Y. So the load current will be taken as positive when it flows from X to Y. Right? This is the notation. Now you have VT1 which is positive and this end is positive and this end is negative, of course, and VTA, this is positive and this is negative. Okay, this one is TA, which is the auxiliary SCR. Then diode, then inductor. The most important thing here is to know about this thing, this particular element, which is capacitor, because one of the names of this particular chopper circuit is also parallel capacitor turn off chopper. So that means majorly this particular capacitor will play very important role in turning off this SCR or turning off the auxiliary SCR. Means both SCRs will be turned on or turned off because of the capacitor connected between these two here, and it falls generally in parallel to the main SCR. Okay, when you apply network analysis, you will see that this capacitor falls in parallel to the main SCR, and that is why we call it a parallel capacitor, right? Now, this part of the circuit, this part of the circuit is the commutating circuit basically. This is the main SCR, and all these capacitor, auxiliary SCR, diode, and the inductor, they form a circuit which we call as commutating circuit. And all these elements are generally commutating elements, right? Means which are responsible for the turn off of the main SCR, right? Now we have to see that initially at time t is equal to 0, this is an assumption that the capacitor C is charged with a voltage which is given by plus on the upper plate and minus on the lower plate, and the voltage across capacitor is VC and the current through capacitor is IC. So these directions of VC and IC need to be taken as positive, right? So at time t is equal to 0, we are assuming, so we will start our explanation for the working of this chopper with an assumption that initially at time t is equal to 0, the main SCR is basically sorry, main capacitor, commutating capacitor is basically charged with a voltage VC, right? Now, how is it possible to have VC across the capacitor? That can be the question. How is it possible to have VC here? So there is a provision made basically. You can see there is a switch connected here and there is a resistance RC. C here is for the capacitor. So the main purpose of this RC is to limit the current basically. Okay. When the capacitor is connected across the main supply. For example, initially VT1 is not conducting, T1 is not conducting, TA is also not conducting, diode is also not conducting. So this whole part, this one, is completely disconnected from the main supply, right? Because when SCRs are not conducting, diode is not conducting, that means they are behaving as an open path. So that means no current will flow from any of these paths, right? So that means now when you switch on this, when you connect this switch, when you turn on the switch S, so what happens? This capacitor gets connected with the supply and the current will flow like this. So current will flow from the plus terminal and capacitor and switch and RC and negative terminal of the supply. And that is why this capacitor will charge with a voltage VC with upper plate positive and lower plate negative. This is the one way to have capacitor initially charged with a voltage VC, right? The second way or the second reason that we can have this capacitor charged with a voltage VC is that let us say this SCR TA is conducting. So when TA will conduct, so it will behave as a short path, okay? Because while discussing the power electronic circuitries, we generally assume that all the electronic devices, that means diodes or thyristors or any other semiconductor device, is an ideal element. Now, ideal element means that these semiconductor devices do not have the on state voltage drop. That means they do not possess any resistance. They do not exhibit any resistance when they are on, right? So this point will be short circuited here, right? So this is again an assumption, right? So this point will be short circuited. So let us say it is completely discharged initially. So how to get a capacitor which is charged with VC, voltage VC, V for voltage, C for capacitor. So when this is the case that TA is turned on, let us say, so the current will flow from plus terminal of the battery and through capacitor, then TA, then here, then through load and back here. So when this is the case, the upper plate of the capacitor will be positive and lower plate will be negative. So with time, the capacitor will be fully charged with voltage VC. Okay, and when it is completely charged with voltage VC, it will be open, and when it is open, the current which was flowing here will become zero, and the current is the same current is because flowing through the auxiliary SCR-TA. So we know that to turn off any SCR, there are two things basically. One is either we apply a sufficient reverse voltage across the conducting SCR, okay, or second is that we suppress its anode current below a value of holding current, okay, so that it is turned off, right? So this is the second case basically. That means when the current was flowing through this capacitor like this, it was getting charged. So it is getting charged slowly and slowly as per its capacity and as per its characteristics. So it will get fully charged. So once it will get fully charged, it will behave as an open path. And when it behaves as an open path, this current which was flowing will become zero. So that means for TA, that current is anode current actually. If you see, for TA, it is anode current, right? So it's an anode current of TA will become zero. So that means it will turn off. Okay, it is turned off, then the auxiliary is turned off, right? So there are two ways by which we have capacitor C charged initially with a voltage VC, right? And this voltage VC is equal to VS. Because if you apply KVL, so you will have the value of VC here. So at time t is equal to 0, VC is charged, capacitor is charged with a voltage VC which is equal to VS, supply voltage. Only then it will oppose the flow of current and make the current zero. Okay. So let us come to next point. So TA, C, D, E, D and L make the commutating circuit. The load is RLE type, right? Okay, now working. So let us assume that the capacitor C is initially charged with polarities as shown in the circuit. So the polarity which are shown are the initial polarities. So these polarities and the current direction is assumed to be positive, right? And this is the whole story here which I have just explained, that these polarities of capacitor are possible only if the switch S is closed and this and that. I have explained this one just now. Now the chopper circuit. So now let us start the working of the chopper circuit at time t is equal to 0 with an assumption that VC is equal to VS, right? And the other assumptions are load current is assumed to be constant, because as we have seen that the application is where the load fluctuation is not very large, means negligible load fluctuation is there. So theoretically you can say the load current is almost constant, right? all the SCRs and diodes are ideal elements. Okay, ideal elements means we do not exhibit the resistance when they are on, working, operating, right? So the chopper circuit works in 4 modes. So there are 4 modes of operation of this particular circuit. So let us start with the mode 1. So it is very simple. It is totally network analysis, totally network analysis. So just try to listen carefully. At time t is equal to 0, I have also drawn the waveforms of each mode, right? At time t is equal to 0, the capacitor is charged with a certain voltage Vc, which is equal to Vs, one thing. Your main SCR is turned on, second thing. So the load current will flow from plus of Vs through T1, remember, through T1, then load, and then back to the supply. This is one thing. Second, because main SCR is conducting at time t is equal to 0, it is conducting. Okay, so the capacitor will discharge because the capacitor current will find its path now. Right? You can see this is positive and this is negative. Let us come to the main circuit. This end is positive and this end is negative of capacitor. So TA is reverse biased because this is negative here. So this point is also negative, so diode will be forward biased. So that means it will be short, right? So this is what we have shown here. Auxiliary SCR is reverse bias, so it will be open. Diode is forward bias, it is short. So that means the capacitor current IC will get its path and it will flow like this. It will flow from here, it will go to the main SCR and then it will come back. It will not go this side. So it will come to through L and then D and it will come back to capacitor. This is the resonating circuit basically. Okay, this is the resonating circuit and it will create a current which will increase from 0 to a maximum value and then decrease back to 0. So it will give an oscillatory current, a sinusoidal current. Okay, because you have a capacitor also connected in the path, right? So there are two things happening. The load current is flowing from the outer region and the capacitor is flowing within the resonating circuit. I have shown the direction here, IC, this one. IC will flow like this. Now what will happen? Apply KVL here or apply network analysis here. Using KVL, you will get V0 is equal to Vs. If you apply KVL in the outer circuitry here, Vs minus V0 is equal to 0. So Vs is equal to V0 or V0 is equal to Vs. The duration of this particular mode of chopper is assumed to be from 0 to T1. T1 is some arbitrary time, okay, for which the main SCR is on. Okay, this is the turn on time of main SCR, right? So I have written all the points here. Load current I0 flows through Vs, T1 and all this. The charging current flows through C. The charging current or capacitor current flows through C, T, L and D and back to C, right? The waveforms are shown here. Capacitor current IC. The capacitor will start discharging. It is actually discharging. So it will discharge. So the capacitor current will increase to a peak value which is equal to ICP. I for current, C for capacitor and P for peak. So ICP is the peak value, right? So at T is equal to T1 by 2. At T is equal to T1 by 2 means half of the, at the half duration, middle of the duration. The value of capacitor current is peak, maximum. So you can see by using KCL, by using KCL. If you apply KCL here, so the current through main SCR is IT1. Current through main SCR is IT1. IT1 is equal to I naught, and from here you have IC. So IT1 is equal to, this is IT1 here. So if you apply KCL, you will get IT1 is equal to IC plus I naught. Okay, this is the equation. Now you can see, so you can see here the waveform of IT1, thyristor main SCR current. So it is actually, अगर just try to understand, मान लीजिए आपका ये पार्ट जो है कंडक्ट नहीं कर रहा है, it is not at all participating. So what is the value of IT1? I naught only, right? क्योंकि ये करंट तो है ही नहीं. So इसका मतलब ये है कि आपका यहां पे आप देख सकते हैं, यहां पे IT1 is equal to I naught at time t is equal to 0. But यहां पे कुछ, it is some curve is shown here. This indicates the capacitor current because IT1 is sum of I naught and IC. That is why for this particular duration from 0 to T1, IT1 is equal to I naught plus IC, right? और जैसे ही आपका T1 पे IC करंट 0 हुआ, IT1 वापिस क्या हो गया? I naught हो गया, right? Okay. Now what will happen to the capacitor voltage? अब आप देखिए ध्यान से कि initially at time t is equal to 0, capacitor, it was an assumption basically जो हमने कहानी अभी बताई, VC जो है VS के बराबर था. So जैसे जैसे कैपेसिटर डिस्चार्ज हुआ, और अपने पीक करंट पे पहुंचा, so the capacitor voltage will become 0. Now what will happen if you have clearly understood the working of this particular circuitry, you can see that the capacitor current is discharging like this. So capacitor current itself is charging the capacitor with this polarity plus and minus. So that means अगर मैंने अपर प्लेट को प्लस और लोअर प्लेट को नेगेटिव लिया है और मैंने कहा कि VC जो है VS है और पॉजिटिव है, तो इसका मतलब जब ये करंट वापस ऐसे फ्लो करेगा, सर्कुलेट करेगा, सो ये कैपेसिटर को चार्ज कर देगा. अपर प्लेट लोअर प्लेट प्लस हो जाएगी, अपर प्लेट नेगेटिव हो जाएगी. वोल्टेज कितनी होगी? माइनस VC, यानी कि माइनस VS, राइट? माइनस VS. सो VC इज इक्वल टू माइनस VS. तो इसका मतलब ये है जब पूरा ड्यूरेशन मोड 1 खत्म होगा, एट द एंड ऑफ मोड 1 what will happen? Your capacitor is now charged with a reverse voltage which is minus VS, right? ये वेव फॉर्म्स हैं. बाकी सारी कहानी जो अभी बताई है वो यहाँ पे लिखी हुई है, राइट? यहाँ पे आई हैव मेंशन द समरी ऑल्सो. एट टाइम t इज इक्वल टू 0 क्या है, और मिडल ऑपरेशन में क्या है, देन एंड ऑफ द ऑपरेशन एट टाइम t इज इक्वल टू t1 पे क्या है, ये सारा यहाँ पे समरी लिखी हुई है. आप इनको चाहे तो यू कैन verify from the waveforms also, right? So this is what actually will happen in mode 1. So mode 1 में क्या हुआ? Main SCR is conducting, capacitor will start discharging, and it will recharge with a negative voltage. Its current will increase to a peak value and then decrease to 0, right? Now let us come to mode 2. So at mode 2, at t is equal to T2, at t is equal to T1, sorry, at t is equal to T1, 0 से T1 तो क्या था? Mode 1. So T1 से T2 let us say is mode 2, right? So mode 2 का initial time क्या हुआ? T1. Final time क्या हुआ? T2, right? At T1 जहां हमने mode 1 को छोड़ा था, वहां पे mode 2 शुरू हुआ. So at time t is equal to T1, जो उसकी कंडीशन थी वो as it is continue होती है. As it is continue होती है means the load current will flow through the main SCR and load and back to the supply. Capacitor is now charged with negative voltage व्हेन कैपेसिटर इज चार्ज विद द नेगेटिव वोल्टेज, क्योंकि यहाँ पे डायोड कनेक्टेड था, हम मेन सर्किट में आते हैं, क्योंकि यहाँ पे डायोड कनेक्टेड था, अब आपका कैपेसिटर ये प्लस हो गया, ये माइनस हो गया, सो क्या हुआ, आपका डायोड रिवर्स बायस हो गया, तो ये ओपन हो गया सब पाथ, तो इसका मतलब चार्जिंग करंट, कैपेसिटर करंट वो भी जीरो हो गया। लेकिन इसमें एक बात ये हुई सेकंड मोड के स्टार्टिंग पे, क्योंकि कैपेसिटर जो आपका है इट इज पॉजिटिवली चार्ज विद लोअर प्लेट, सो द ऑक्सिलरी एससीआर का जो एनोड है वो पॉजिटिव हो गया, so that means anode of the that means auxiliary SCR is under now forward blocking mode। आपको इसे ट्रिगर करना पड़ेगा, अगर आप इसको रन करना है तो आपको इसको ट्रिगर करना पड़ेगा, ये टर्न ऑन नहीं हुआ है तभी, इसलिए इस मोड में भी इसको ऑफ दिखाया गया, बट इट इज फेवरेबल फॉर दी फॉर टर्निंग ऑन, ओके राइट। सो यहाँ पे सारा ये सब चीजें दिखाई गई हैं, वेरी इजिली यू विल अंडरस्टैंड। लेट अस कम टू दी थर्ड मोड ऑफ इट्स ऑपरेशन। थर्ड मोड में क्या हुआ, अगर आप इसको देखो, अब यहाँ पे बड़ी अच्छी बात ये हुई कि बिकॉज दिस एंड ऑफ द कैपेसिटर, द लोअर एंड ऑफ द कैपेसिटर इज पॉजिटिव, इट विल मेक द ऑक्सिलरी एससीआर टर्न ऑन। सो लेट अस से वी हैव ट्रिगर्ड द मेन एससीआर, let us say we have triggered the auxiliary SCR at T3, at T3 मोड 3 पे आ गया। अब हम मोड 3 कहां से कहां तक है, T2 से T3, सॉरी, at T is equal to T2 we have triggered the auxiliary SCR। so as soon as we will trigger the auxiliary SCR, what will happen, the voltage across this capacitor, क्योंकि ये पॉइंट जो है नेगेटिव है, तो इसका मतलब मेन SCR का एनोड जो है नेगेटिव एक्सपीरियंस कर रहा है, right? So main SCR will get into the turn off condition। लेकिन क्योंकि अब आप पूछोगे सर मोड 2 में टर्न ऑफ क्यों नहीं हो गया, मोड 2 में इसलिए टर्न ऑफ नहीं हो क्योंकि ऑक्सिलरी एससीआर को आपने ट्रिगर नहीं किया था, यहां से कोई करंट नहीं फ्लो कर रहा था, सो जो लोड करंट है वो बाहर से फ्लो करता रहेगा, दो यहाँ पे ये पॉइंट नेगेटिव है। लेकिन मोड 3 में क्या हुआ, आपने जैसे ऑक्सिलरी एससीआर को टर्न ऑन किया एट टी इज इक्वल टू T2, क्या हुआ, जो लोड करंट है उसने अपना पाथ बदला एंड इट विल फ्लो थ्रू सी टी एंड लाइक दिस, and immediately at T is equal to T2 the voltage that was here that will appear across the main SCR T1, and this voltage as it is because is appearing across T1 which is equal to Vs or minus Vs, so it will reverse bias the main SCR and suppress its। अब यहाँ पे दो चीजें हुई, एक तो इसके क्रॉस रिवर्स वोल्टेज आ गई, दूसरा जो इसका जो एनोड करंट था बेसिकली जो यहां से फ्लो कर रहा था, जो कि लोड करंट है, लोड करंट यहां से फ्लो कर रहा था, सो दैट करंट गेट्स डिवाइडेड हियर। सो दो बातें, रिवर्स वोल्टेज और लोड करंट भी डिवाइड हो गया, सो इसका एनोड करंट वैसे ही रिड्यूस हो गया और ऊपर से वी हैव अप्लाइड द रिवर्स वोल्टेज, सो द रिवर्स वोल्टेज इज सप्रेस द एनोड करंट एंड bring the main SCR into off state, right? Now the load current will flow through capacitor TA and load and back to supply। अब क्या होगा इस मोड के एंड पे, अब समझना इसको ध्यान से। So let us come to the mode 3. Okay, now what I hope you must have noticed that when the current is flowing through capacitor and TA and this, now what actually is happening, you can see, you can notice it. If you apply KVL in this path, this is the path, right? अगर आप इस मैश में KVL अप्लाई करो KVL, write down the equation you have, Vs plus Vc minus V naught is equal to 0. So V naught here will be equal to 2Vs, twice of supply voltage। I'm sorry, twice of supply voltage, right? अब आप ये कहोगे सर Vc तो माइनस Vs के बराबर है, तो इसमें प्लस Vs कैसे ले लिया? So basically minus Vc is minus Vs because we are taking it as reverse with respect to the reference polarity, upper plate positive, lower plate negative। However, when we apply KVL, we have to deal with the magnitude only, which is equal to Vs, right? Now, you can see that this is the equation here, KVL equation. Now when the current is flowing in this path, there are two things happening. One is V naught is equal to twice of Vs, Second is you must notice that the capacitor was charged at the start of this mode 3. The capacitor was charged with lower plate positive and upper plate negative, and it will give path as soon as you turn on the auxiliary SCR. It will give path to the load current. Also, this capacitor will discharge through this path. It will discharge, but because the current is flowing through it, the main current, the load current is flowing through this capacitor, that load current will charge this capacitor again with the upper plate positive and lower plate negative. Upper plate positive and lower plate negative. इसको देखना समझना ध्यान से पेन पेंसिल यूज करके, right? So this is the summary of mode 3 here, okay, and these are the waveforms. IC is equal to minus I naught. Now why it is minus I naught? You can ask why it is minus I naught, because if you come to the main circuitry, if you come back to the main circuit of the chopper, the positive direction of IC is upward, okay. But now in this case, what actually is happening here in mode 3, the current through capacitor is flowing downward. यही बात मैंने थोड़ी देर पहले बोली कि लोड करंट तो इसके थ्रू फ्लो करेगा ही करेगा, साथ के साथ जो कैपेसिटर करंट है दैट विल द कैपेसिटर विल आल्सो डिस्चार्ज, मीन कैपेसिटर करंट भी यहां से डिस्चार्ज हो रहा है, यानी कैपेसिटर करंट की डायरेक्शन भी रिवर्स हो गई. सो दैट इज व्हाई द कैपेसिटर करंट इज शोन नेगेटिव हियर. वन थिंग. Second, IT1 is 0, no current is flowing through main SCR, it is 0, right, for this duration. Then VC and VT1, two voltages here. VC, अभी मैंने आपको क्या बोला कि कैपेसिटर डिस्चार्ज हो, लेकिन जो मेन करंट इससे फ्लो कर रहा है उसको चार्ज भी कर रहा है, तो ये लीनियर ऑपरेशन है. क्यों? बिकॉज द लोड करंट इज कांस्टेंट, ओके, सो इट विल लीनियरली चार्ज इट, ओके. सो लीनियरली आपका वोल्टेज जो है कैपेसिटर के क्रॉस वो माइनस वीएस से प्लस वीएस हो जाएगा. बीच में टीसी दिखाया गया, टीसी इज द सर्किट टर्न ऑफ टाइम, ठीक है. सर्किट टर्न ऑफ टाइम का मतलब ये है कि आपका सर्किट जो है वो उसका जो टर्न ऑफ ड्यूरेशन है बेसिकली. सो लेट अस कंटिन्यू द लेक्चर. नाउ यू कैन सी हियर दैट I naught IC is negative, that I have explained, and the capacitor will charge from minus Vs to plus Vs, right? The same voltage will also appear across the main SCR. यहाँ पे दो चीजें लिखी, if you see, and VT1. आपने अगर नोटिस ना किया हो तो मैं बताया था, VC and VT1 दोनों का ये सेम वेवफॉर्म है, ठीक है. इसका मतलब ये है that कि when your capacitor will charge, अब इसको समझना है सारा फिनोमिना को. अब क्या हो रहा है कि द करंट इज फ्लोइंग इन दिस पाथ मोड 3 में, कैपेसिटर इज गेटिंग चार्ज विद टाइम, राइट, एंड एट सम पॉइंट टीसी, एट सम टी इज इक्वल टू टीसी जो अभी लिखा हुआ था, अगर आपने देखा हो यहाँ पे, देन यू मस्ट नोटिस दैट टीसी द वोल्टेज अक्रॉस कैपेसिटर इज 0 एंड वोल्टेज अक्रॉस मेन एससीआर इज ऑल्सो 0. व्हाट डज इट मीन? It means that at that particular point of time, we don't have any plus or minus here. It is totally neutral. So that means this end of the main SCR will come under the effect of positive supply voltage. One thing. So इसका मतलब ये है कि now आपका इसके बाद तो main SCR है, that may be turned on if required, right? That may be turned on if required, right? Now the voltage will increase to plus Vs, okay. That means at the end of this particular mode where t is equal to t3, where this mode ends at t is equal to t3, the capacitor voltage and the voltage across the main SCR is plus Vs. The current through the capacitor current is 0. Now why the capacitor current is 0? Because with the time, since the voltage across this capacitor, voltage across this capacitor will be equal to this one. It will be plus and minus. कितना वोल्टेज आया T3 पे, प्लस Vs आया ना यहाँ पे, ठीक है. So that means again the same polarity, reference polarity के साथ कंपेयर करेंगे. So it is plus and minus, okay. So when it is fully charged, so this current जो ये current flow कर रहा था क्या होगा, ये 0 हो जाएगा. अब this current is the anode current for main SCR, जो शुरू में हमने कहानी बताई थी, याद होगा आपको, कि हाउ डू वी गेट the capacitor charged with VC initially. Okay. So if you see this current is the anode current of the main auxiliary SCR. So when this capacitor is fully charged, it will suppress the anode current of main SCR, and when we suppress the anode current of main SCR to 0, the SCR will be turned off, right? Okay, so this SCR is also turned off. This means at the end of mode 3, your main SCR is off, though it is in the favorable condition to turn on. You can turn it on if required, but it is not turned on. You have not triggered the main SCR. Your auxiliary SCR is also turned off. Now your diode was turned off, but no current will flow here because capacitor current is not getting any path. ये भी open है, ये भी open है, so it will also be open. Otherwise, at the end of mode, you can see the lower plate of the capacitor is negative. So this यहाँ पे जो diode था, उसका cathode जो है वो negative है. So it is forward biased actually, but as of now it is shown as an open path because no current will flow here. Now this is what will happen at the end of mode 3. So the summary has been explained here. At t is equal to t2, because mode 3 will start at t is equal to t2, it will end at t is equal to t3, right? So at t is equal to t2, all these parameters are there. T is equal to tc, means at almost at the center of the duration, middle of the operation. All these parameters have been mentioned. The state of all these parameters have been mentioned. At the end of this particular mode, mode 3, the state of all the relevant parameters have been mentioned here, right? Now let us come to mode 4. So at mode 4, which basically exists from T3 to T, right? So you can see that here the capacitor is charged with plus voltage Vs, upper plate positive, lower plate negative. Auxiliary SCR is off, main SCR is off. So even if capacitor has to discharge, it cannot discharge from any path because main SCR is off. The current cannot flow back. Okay. Okay, but if it needs to flow back, you need to turn on this switch. Okay, so that cannot also happen. It cannot also happen. Okay, the current cannot flow back to the main supply even you turn on the main switch, right? So in mode 4, you can see main SCR is off, auxiliary SCR is off, diode is off. So this part and the load part of the chopper circuitry is totally disconnected now. Okay, now here comes the role of freewheeling diode. Now freewheeling diode will get forward biased because now inductor will start releasing the current stored in it through freewheeling diode. So it will make the freewheeling diode as forward biased. So freewheeling diode will become short. So this point and this point will become short. Now if we apply KVL in this mesh, so V0 will be equal to 0. Why V0 will be equal to 0? Because this is short now. So V0 is equal to 0. And the load current will keep on flowing in the same direction. जो हमारा reference direction है I0 की, which is positive. So in the same direction, the load current will keep on flowing. So for mode 4, it is also known as freewheeling mode, basically mode 4, right? In this mode, the capacitor will charge is initially at the start of this mode at t is equal to t3. Capacitor is charged with the voltage Vs, plus Vs. Main SCR is off, auxiliary SCR will be turned off, and D is open. Okay, freewheeling diode at the start of this mode, freewheeling diode will come into action, right? So all the relevant waveforms are shown here. You can see. So I have made it dark so that it is clear that the value is 0. Okay. And the summary is given. A summary of all the parameters, means state of all the parameters has been written here. Now you must have noticed here that there are two things basically. If you see, there are two things. One is the capacitor and second is the inductor. Okay, so this makes this whole circuitry as a resonating circuit, right? So L and C play a very important role in the commutating circuit basically. Okay, so their values matter. Okay, so their values are very important. So we must know what should be the value of C and L, because we are saying You could have asked me the question that how is it possible to have a capacitor voltage to turn off the main SCR? Okay, so that means the value of capacitor should be such that the voltage of capacitor which appears as a reverse voltage across main SCR should be sufficient to turn off the main SCR. This is the important thing, right? So that value of capacitor needs to be calculated. Okay, so in design consideration we can see the value of capacitor. So for mode 3, basically if you see for mode 3, the main SCR is off basically, because the main current is 0 here, main SCR is off. So for mode 3 sorry, the capacitor current, let us say the equation of capacitor current or charging current basically is C dV by dt. So the static value of this equation can be written as IC is equal to C Vs by Tc. Right now, so from here you can have the value of C is equal to Tc I naught in I naught, because IC is equal to I naught. IC is equal to I naught. So ये current flow करा ना, so the capacitor current is equal to the I naught, right? So IC is equal to I naught, तो ये equation हमारे पास आ गया. अब circuit turn off time TC must be greater than the SCR commutation time. Now I hope you all know what is circuit turn off time. What is the difference between circuit turn off time and SCR commutation time? Okay. So circuit turn off time is the time, the duration for which circuit is turned off should be more as compared to the time or duration for which the main SCR is commutated or turned off, right? Okay, turning off an SCR is something else and turning off the main circuit is something else, right? So the circuit turn off time is equal to TQ. TQ is the SCR commutation time, and let us say it is TQ plus delta T. Means we mean to say that the circuit turn off time is kept slightly greater than the main SCR commutation time. The circuit turn off time is kept slightly greater than the commutation time of main SCR. You can see here. Okay, so by putting TC is equal to TQ plus delta T in this equation, you have C is equal to TQ plus delta T into I naught divided by Vs. So this equation number 9 gives the value of capacitance. That means the value of capacitance of the capacitor used in the commutating circuit or as a commutating element depends upon the SCR commutation time, some delta T, okay, I naught, the load current, and the supply voltage Vs. Okay, on all these values the value of the commutating capacitor depends. Similarly, the value of commutating inductor can be obtained. So if you see, IC is equal to Vs by omega naught L sine omega naught T. Now how did we get this equation? We got this equation. Let us come to the main mode. So here you can see, so you have a sinusoidal wave basically. So this duration is pi. So you can see omega T1 because the duration is T1 is equal to pi. So T1 is equal to pi by omega naught, right? So so you can see that when the main SCR is turned on, the current IC flows through C, T1, L and D. This current is given by IC is equal to Vs by omega naught L. This is the same equation which we obtained in case of the inductive circuits basically. So you have the equation IC is equal to Vs upon omega naught L sine omega naught T, where omega naught is the resonating frequency here, which is 1 upon under root LC. Okay, or F is equal to 1 upon 2 pi under root LC. So the peak current, ICP, peak current, it is shown in the waveforms. If you have noticed, it is shown in the waveforms here. So okay, peak current, this one. Okay. So So the peak current is given by Vs by omega naught L. So you can replace this equation with an equation which is equal to IC, where small I is the instantaneous value of charging current, is equal to ICP sin omega naught T. So that means ICP is equal to Vs divided by omega naught L. Okay, from here you can replace omega naught with 1 upon under root LC, and rearranging this equation you get ICP is equal to Vc square root C by L. Okay, so when T1 is turned on, the current through T1 IT1 is given by, अब ये वो सेम चीज आ गई, क्योंकि जब आपका मेन एससीआर ऑन है और कैपेसिटर डिस्चार्ज हो रहा है, सो जो करंट है मेन एससीआर के थ्रू, वो ना सिर्फ लोड करंट होता है पर डिस्चार्जिंग करंट भी होता है, यानी दोनों का सम। पहले वाली इक्वेशन आ गई। अब जो पीक वैल्यू है यहाँ पे बड़ा एक इंपॉर्टेंट रोल प्ले करती है। सो दिस पीक वैल्यू शुड नॉट बी लार्ज बिकॉज इट मे डैमेज द मेन एससीआर। ओके, इट मे ब्रिंग सम थर्मल रन अवे इन द मेन एससीआर, क्योंकि उसका जो एनोड करंट है, बिकॉज IT1 इज नथिंग बट द एनोड करंट। ओके, इफ IC इज 0 देन एनोड करंट इज इक्वल टू I नोड। ये भी हमने वेव फॉर्म में समझा। But now the capacitor is also discharging here side by side, so capacitor current will add to the I node, so the anode current will increase. Now if anode current will increase, this may bring your main SCR into thermal runaway condition. So it may कहाँ पे लाएगा thermal runaway condition? J2 junction 2, which is reverse bias basically. Okay, so now the value of IC यानी कि पीक वैल्यू ऑफ IC which is ICP वो ज्यादा नहीं होनी चाहिए, और उसका वैल्यू क्या, उसको जनरली हम लोड करंट से कम रखते हैं ताकि IT1 बहुत ज्यादा एक्सीड ना कर जाए। सो लेट अस से ICP is less than equal to I नोट। सो फ्रॉम हियर वी हैव, और ICP किसके बराबर है, पीक वैल्यू Vs बाय ओमेगा नोट L या Vs अंडर रूट C बाय L की। तो जब हमने उसको यहाँ रखा और इसको रीअरेंज किया, तो हमारे पास L की वैल्यू है L should be greater than equal to Vs by I naught square C. That means the value of L which is to be used in the commutating circuit can be calculated by using all these parameters: the requirement of load current, the supply which you are giving, and the value of capacitance. So equation number 13 gives us the value of L used for commutating circuit in case of voltage commutated chopper. So guys, this was all about today's lecture. If you have any query, you are most welcome. Any query?
कब तक चलेगा ये सर?
अभी कब तक चलेगा तो मुझे भी नहीं पता, सरकार को पता है। और बट ये है कि आप लोग थोड़ा सा keep on reading all these notes. I have tried to make these notes as simple as, though I am following the same book P.S. Bhimra only, right? But I have tried to make the notes quite simple for you. Okay, just go through those.
और ये जो हम डेरिवेशन कर रहे हैं इस वाले टॉपिक में, इसके ऊपर हमारे न्यूमेरिकल क्वेश्चंस हैं?
Yes, अभी हम इस वीक जो है जो ट्यूटोरियल शीट करेंगे वो इसी पे करेंगे। अभी जो उसके बाद हमने जो किया है उन पे करेंगे, और हमने बेसिकली जो स्टेडी स्टेट एनालिसिस किया था on that we will have some numerical, then on voltage commutated chopper we will have some numerical, then tomorrow our topic is current commutated chopper tomorrow, ठीक है? सो उस पे भी हम कुछ मतलब चीजें समझेंगे, पढ़ेंगे। तो न्यूमेरिकल तो है ऑब्वियसली है, और इस वीक पे यानी कि फ्राइडे को देयर विल बी अ स्मॉल टेस्ट ऑन दिस यूनिट. So I will inform about the way or format of the question paper and mode of implementation, right? Harshita, do you have any query, beta?
No sir. No sir.
So thank you so much. Take care.
Thank you sir.
Okay.
Thank you sir. Take care sir.